Lesson 2. Fun with functions, linear ones, making sense of different representations of a linear function. Let's get started with the warm-up. Determine the slope of the line between each pair of points. The first point, for number 1, we have 0 and 10, and 3 and 12. Label your orders pairs. This is your first x, this is your first y, this is your second x, and this is your second y. The slope formula is second y minus your first y divided by your second x minus your first x. Your second y would be 12 minus your first y, which is 10. Your second x will be 3 minus 0. 12 minus 10 gives you 2. 3 minus 0 gives you 3. So there, the slope, or the rate of change, will be 2/3. The second problem, number 2, you have -1 and 4.5. You have 1 and -4.5. This is your first x, this is your first y, this is your second x, this is your second y. So my second y minus my first y over the second x minus your first x to find your rate of change will be -4.5 minus 4.5, 1 minus -1. So the top I'm going to get 0, and on the bottom I'm going to get 2. Oops, I'm sorry. -4.5 and -4.5 do not cancel out, and that gives me -9. I've got -9 over 2. So that's in simplest form. So that gives me a negative slope. Number 3, I have -1 and 0, and 0 and 12. This is x1, y1, x2, y2. So 12 minus 0 over 0 minus -1. I've got 12 over a +1, which reduces down to 12 as my slope. Read over your learning goals and some key terms that we're going to look at in this lesson. You know how to determine whether a relationship represents a linear function, and you know how to write an equation for the function. How can you use the structure of the equation to identify characteristics of the function? Getting started. Well, are ya or aren't ya? Determine whether each representation models a linear or nonlinear function. Explain your reasoning. All right, so we've got 3 scenarios, 3 equations, and 3 tables. And we're going to look at each one of them to determine whether they are linear. And we also have 3 graphs. Scenario A tree grows 3.5 inches per year. So each year, that tree is growing 3.5 inches. This is linear. We can see that my slope is 3.5. Scenario B. The strength of a medication decreases by 50% each hour it is in the patient's system. Well, we had a similar problem like this when we were talking about exponential growth and exponential decay. This is nonlinear. Scenario C. The area of the square depends on its side length. The area of the square depends on its side length. This is nonlinear. We do not see a constant rate of change. Equation A. Let's think about slope-intercept form. Y equals mx plus b. Equation A looks like slope-intercept form. When we see that x to the first power, we know that it is linear. Equation B, notice that you have an exponential here. You've got x as an exponent, so this is nonlinear. Equation C, if I distribute in that 1/4 x and combine the 1/4 x times 7, take away, I'm still going to have this x. And that x is to the first power. So anytime you have x to the first power, it's going to be linear. So equation C is linear. I'm going to clear this off and look at the tables. Table A. Going back to the directions, it said we are looking for a linear or nonlinear function. Remember, function means that your x values do not repeat. So if I go back and look at table A, I'm seeing that this is not even a function. Not even a function. B, it is a function, and we need to determine if it's linear or not. If we take table B and plot these points to give you a visual, the points were 3 and 1, 4 and 1, and 5 and 1. So this is a linear function. Let's look at table C. Table C, we could also plot these points, or we can calculate the rate of change. I notice that my x values are increasing by 1. The difference of my y's would be 30 minus 45, which gives me negative 15. (15 minus 30 also gives me a negative 15. And if I do, and that gets it. So that gives me a constant rate of change. So that is also a linear function. Graph A. It is a function, but it's not linear. B is a linear function. And graph C is linear, but it's not a function. You can see here that all your x values will be repeating. Activity 2.1, interpreting linear functions. Each table of value in the previous activity had consecutive input values. Tables in that format allow you to use differences to determine whether the representation is linear. Often input values are in the intervals other than 1, and sometimes the input values are in random order. To determine whether these tables represent linear functions, you need to make sure the slope, or the average rate of change, is constant between all given points. Remember that your slope formula is your second y minus your first y over your second x minus your first x. So here, for table A, if I do 4.75 minus 5.5, that's going to give me a negative 7.5. Negative 0.75, excuse me. And then over here, the difference of my x's will be 1 minus negative 2, which gives me 3. So if I divide that by 3, that gives me negative 0.25. So that would be my slope. And I could test that again with some different values, but I see that I'm going down here by 0.75, and I see that I'm also increasing here by 3. So this is definitely constant. So this is my slope, and it says to write a function. So I've got my slope, and now I need to find the y-intercept. So what I'm going to do is I'm going to take my slope-intercept form, and I'm going to take one of those points. Let's say 4 and 4. That was an easy point to use. That was in the table. And then I'm going to use this slope down here. So this is an x, this is a y. So I'm going to plug those in. So I'm going to plug 4 in for y, negative 0.25 for my slope, and 4 in for x. And I'm going to solve for b. I don't know what my y-intercept is, but I'm going to solve for it. So 4 times a quarter gives me negative 1. Add 1 to both sides so that you can isolate the b. Those cancel out. We're just solving the equation. So b equals 5. So take your y-intercept, take your slope, and put it in slope-intercept form. Y equals negative 0.25x plus 5. So there's our function for A. For B, start out doing the slope. Notice right here, that's our y-intercept if it's linear. Let's check. So let's see, I'll do 13 minus 5. Gives me 8. Here, 2 minus 0 gives me 2, so I'm increasing by 2, but here I'm increasing by 4. So it's not constant, it's not the same. So even though it is a function, it's not linear. So if it's not linear, I can't put it in slope-intercept form. Analyze each situation represented as a table of values. Dylan sells pretzels at festivals on weekends. The table shown is a record of past sales. What does this table tell you about his sales? How much money did Dylan earn if he sold 175 pretzels? All right, so let's look at our rate of change. Let's look at our slope here. If I do 105 minus 37.5, that's going to give me a 67.5. And over here, 42 minus 15. So keep in mind, these are the difference of my x's, these are the difference of my y's. So 42 minus 15 gives us 27. So 67.5 divided by 27 gives me 2.5. So let's see if this works out again. If I do 145 minus 105, it gives me 40. Over here, if I do 58 minus 42, it gives me 16. 40 over 16 gives me 2.5 again. So we can say that 2.5 is the slope, it's the rate of change, it's the rate he's earning for each pretzel that he's selling. So we could say that for each pretzel, he is making a profit of 2.5. we could plug in 75 pretzels, y equals 2.5 times 75, to see what he is going to earn. And he should be making $187.50 for selling 75 pretzels. Number 3, Delaney and her friends recently went to the community fair. They had to pay an entrance fee and then purchase one ticket for each ride. Dakota is going to the fair tomorrow and wants to know the cost of each ride. Delaney and her friends helped Dakota by writing down how much money they spent and the number of tickets they purchased. What does this table tell you about the cost to go to the fair and the ride of the rides? So let's see here. The rate for each ride. If I do 9 minus 7.5, that gives me 1.5, so maybe $1.50. And that seems to be what we're increasing here. Let's see, 10.5. Of course, over here we're going by different increments. So here we'll have 4 minus 2. 4 minus 2 is 2. So we'll divide that by 2. So 1.5 divided by 2 gives us 75 cents for each ride. Let's see if it holds true again. So 10.5 minus 9 gives us 1.5. Here, that's going to be 2 again. So that gives us 75 cents for each ride. And then we got to figure out what's the cost to get in. So we've got the slope. We've got the rate of change, but what we don't have is our starting value, our y-intercept. Well, we can go back and do what we did before. Let's take that 4 and 9. Those look like easy numbers. So I've got y equals mx plus b. I said I was going to take 4 and 9. I've got my slope of 0.75. So 9 for y, 0.75, and 4 for x. And we're going to solve for b. 4 times 0.75 gives me 3. So 9 equals 3 plus b. Subtract 3 from both sides. Those cancel out. And my y-intercept is 6. Now keep in mind that your y-intercept is your starting point. So this is when you enter the gate and you have to purchase your ticket to enter the fair. So 75 cents for each ticket plus a $6 entry fee. So part A, what does the table tell you about the cost to go to the fair? The cost is going to be $6 and each ride is going to be 75 cents. Part B, if Dakota has $20 to spend, how many ride tickets can she buy? Okay, so we're going to have to take $20, subtract 6, that gives us $14. Well, if we take $14 and divide by 0.75, that's going to give us 18 tickets. 18 tickets she can buy with $14. Number 4. The local pet store has a fish tank on display at the community fair. Darren is responsible for draining the tank at the end of each fair. The pet store manager provides him with this information from when he drained the tank at the end of the fair last year. How many gallons did the fish tank hold? When will the tank be empty? Part A asks, how many gallons did the fish tank hold? They're actually asking for the y-intercept here. So the y-intercept is when you have 0 and some number. And whatever that number is, that's going to be your y-intercept. When the tank will be empty, they're actually asking for your x-intercept, where it crosses the x-axis. So whatever number's here, and you have 0 here, is going to be your x-intercept. Well, if you look at the table, we're not given that information. We can continue the pattern Or we can figure out mathematically what it's going to be. First, let's calculate the slope. 163 minus 169 gives us a difference of -6. 1/2 minus 1/4 gives us a difference of 1/4. So -6 divided by 1/4 gives us -24. So we're going to use that for my slope. Let's use this as my point. So y equals mx plus b. And I was going to use 1 and 151. So there's my x, there's my y. My slope is -24. So 151 -24 times 1 plus b. So I'm going to add 24 to both sides. 151 plus 24 gives me 176. So that's going to be my y-intercept. And that y-intercept, remember, is how many gallons did the fixed tank hold? So 176 gallons. Actually, 175. $175 gallons. Not 176. 175 gallons. So now we can take our equation, y equals -24x plus 175, and we can enter in 0 for the y and figure out what x is. So you've got -24 times x plus 175. So subtract 175 from both sides. You get -175 equals -24x. This is just solving an equation. Divide both sides by -24 to get your x-intercept. So 175 divided by 24 gives you about 7.29. And that represents your hours. So that's your x-intercept, 7.29 hours. So that's about and you can calculate the minutes there, but we can leave that like that, 7.29 hours. That's your x-intercept. And 7.29 hours, that's how long it will take when the tank will be empty. And I think they calculate that to be about 7 hours and 17.5 minutes when that fish tank will be drained. Activity 2.2. Interpreting graphs of linear functions. Marilyn sells silk screened t-shirts for her mom at local festivals. After each festival, she returns whatever money she earns to her mom. The graph shown represents her potential earnings based on the number of t-shirts she sells. Number 1. Analyze and interpret the graph. List as many facts as you can about the scenario based on what you see in the graph and describe how they relate to the scenario. Well, we can calculate the slope. Here I notice that it goes through the origin. And here, so let's see, what does this go by? 1, 2, 3, 4. So they go by 1 on the x-axis, 10, 20, 30, 40, and 10 on the y-axis. So my rise, and remember we said slope is the difference of the y's over the difference of the x's. You can also think about that as being rise over run. So my rise here is going to be 10, 20, 30, positive 30, and my run is going to be 2. So that's going to be a $15 rate. So she's going to make $15 on every shirt. So if she sells 2 shirts, she's going to make $30. So here's 2, and that crosses at 30. If she sells 2 shirts, she's going to make 30. If she sells 4 shirts, she's going to make $60. Number 2, interpret the meaning of the origin. So the origin, 0 and 0, if no t-shirts were sold, Marilyn's not going to make any money. Number 3, write a function, ET, to model Marilyn's potential earnings given the number of t-shirts. So this is number 3. So we have the function ET. Our slope, our rate of change is $15. So 15 times t. My y-intercept is 0. So I could put plus 0, but we typically leave it off. Number 4. What does t and ET represent in terms of the function and the graph? So t is your x and ET is your y. X is your input, y is your output. So t represents the number of t-shirts. ET is the profit that you're going to make. Each t-shirt. Number 5, evaluate each and interpret the meaning in terms of the equation. So for 5, my input would be 2, and remember that it was 15 times x, or ET equals 15 times t. So if I'm plugging in 2 for t, then my output is going to be $30. So in other words, if she sells 2 t-shirts, she's going to make $30. If she plugs in 5 times 15 gives us a profit of $75. If she sells 2.75 t-shirts, I don't know how that's possible. Doesn't make any sense. You can't sell a portion of the t-shirts. I certainly am not going to buy a portion of the t-shirts, but we'll play the game. If you plug in 15 times 2.75, that gives you 41.25. However, this does not make sense. Marilyn has a goal to earn $100 at the festival. Let's consider how to determine the number of t-shirts she needs to sell to meet her goal. To determine the number of t-shirt sales it takes to earn $100 using the function ET equals 15t. Substitute in 100 for ET and solve. Okay, so we've got 100 equals 15t. Then they're going to divide both sides by 15 to figure out 100 divided by 15 gives us 6.67. So we really need to sell 7 t-shirts because we can't sell a portion of it. So 6a, I think we just answered that. We need to sell 7 t-shirts. We can't sell 6.67. Has to make sense. 6b, why can you substitute 100 for ET? Well, 100 is the profit that we want. And remember, ET is the profit. T was the number of t-shirts, and ET was our profit. T-shirts, profit. You can also use the graph to determine the number of t-shirts Marilyn needs to sell to $100. First, the graph the function defined by each of the equation, then determine the intersection points of the two graphs. So here we have HT equals 15t, which is graphed here. And then we have your flat line, which y equals 100, graphed here. And where they intersect is this point right here. In terms of the graph, Marilyn needs to sell 6.67 t-shirts. Number 7, consider the equation and graphical representation. What are the limitations of using each to answer the questions about the number of t-shirts sold or the amount of money earned? So number 7, let's look at the equation. Sometimes an equation provides an answer that does not make sense in the context, and the answer must be rounded up or rounded down. Okay? So sometimes it just might not make sense. It has to make sense. The graph, sometimes it's difficult to read an exact answer from a graph, so it's hard to read that exact answer. So that's why we got both situations to look at.